Welcome to the lecture number 29. We will be talking about peer-to-peer based system called blockchain. This is a very good example how the blockchain has been used. Now basically the idea is that when you read about blockchain, look into anywhere in the literature, nobody will tell you that what kind of peer-to-peer network is underlying, what kind of DST algorithm is in use, okay, and whether it's academia or whether it's a pastry or tapestry, it will not be evident. Only thing which is important is that if the nodes who are there, okay, there may be many nodes in this who are participating, what they will do is I will explain. But if this guy is alive and if some other node is alive, there should be always a network connection, reachability should exist between them. Only if they die off, then the reachability will not be there. But the moment when it comes back, it should be able to again get connected to the network. So important thing is that connectivity should be maintained. That's a very important thing. And this is what is achieved by logarithmic partitioning based routing tables. So it will be a structured system. How now this thing is going to work? This is again what people tried was they tried first important thing that let me explain what's the difference. So if you actually in a real world, if you have a banknotes or currency, so if you give a currency from A to B, you actually do actual transfer of the money. Now what the question is, A cannot spend the same money again because it's not there with him, it's only with B. Okay, while suppose it would have been some kind of a random string and you said, okay, I am going to transfer this money to B. You transfer that random string to B, but you can always retain a digital copy of this. It's a digital transfer basically, it's nothing but a string. Now the problem with this is, even before B spends, you can go and again give it to somebody else and then buy something. And you give him the money, you get the stuff, you can give it to, so you can do multiple spendings of the same money. So we call it a double spending problem. So that was one reason why this was not feasible in a digital domain. Okay. So the way normally the transactions happen in digital domain is when you want to transact to A to B, you always depend on some third party which we call bank. And A will now first of all communicate to bank and say that you kindly transfer the money to B. Some amount, say delta amount has to be transferred. So what bank will do is it will check if A has sufficient balance and once A has sufficient balance, then only bank B will do a transfer to B. It's basically what it will do is maintains a ledger for A, it maintains a ledger for B. Both ledgers are maintained by bank. It will reduce the amount by minus delta here and it will increase the amount by delta here. So the balance will get updated in the bank. Now A goes and wants to do a transaction with C. It is to again talk to the bank. They cannot do a direct transfer. So most of the digital transfers are actually done in this fashion. We are totally depending on the bank. But the problem here is you are depending on the bank, and bank tomorrow can actually make an entry, may reverse these entries. Actually, it may find out something wrong, it may reverse it. That's it. And you are lost. So you are basically depending on the faith on the bank as of now. So people wanted a system because now this depends on bank. Bank will depend on the government regulator. You depend on the countries. Is it possible to do a transaction where you actually can do direct peer-to-peer transfer the way you do cash? So cash actually here all transactions can be tracked, who communicated to whom, bank has the information, so the governments can actually find out all the transactions. But if you do a cash transaction, A gives some 100 rupees to B, there is no record. The only cash is there now with him. There is no record the cash was with whom earlier. Your earlier traces are gone. So whoever has the value, only one record, who has the value, who has the currency at that point of time, that is more important. Okay, and that avoids double spending. So people thought, can we do this thing in electronic domain? So idea is pretty simple now after this. If all these people in blockchain, why we call it a blockchain, I will explain. So all these nodes, if they start maintaining balance of everybody, okay, the life going to be very simple. Let me just first of all give the principle on which this thing works. So we can actually now make another system where all nodes keep track of course the issue is that if there are large number of nodes, how to do it and how to do it anonymously. So let there be a small village and everybody maintains a notebook. Okay. So everybody maintains a notebook, so the person's names are A, B, C, D. And you can also now realize why peer-to-peer communication become important here. So everybody maintains a notebook where say A is having this much balance, B is also having this much balance. So everybody's balance is recorded here. Okay. Then everybody maintains the same copy of the notebook. So records are there. Okay. Now A and B decides that they want to do some transaction, so he is going to sell him something, say maybe some vegetables or something, and A wants to transfer the money. So how the transfer will actually execute. So what A will do is A will check whether B will check whether what is the balance in his notebook, how much A has. So A has sufficient amount of money, perfect. So A and B, both of them will agree that we have sufficient money is there and this much money has to be transferred. So say amount delta has to go from here to here. Now what they will do is once they agree for delta transfer, either of them can communicate to, most likely it will be A because it's A's money which is getting transferred. A will tell it to everybody that kindly reduce this much delta amount from my balance and add it to the balance of B. So everybody will now make an entry of minus delta for A and it will do plus delta for B. So everybody does it. Okay. And everybody confirms this. So once everybody has confirmed, so B will now do a confirmation. Yes, the money has been with each one of them has been confirmed. So the now money has been transferred. Okay, and there is no currency which has been done. It's only the ledger entries have been updated everywhere. And then he can give this particular whatever vegetables he was trying to sell. As a consequence, now there is an updated ledger which shows that the balance with A has gone down and balance with B is higher. Now A want to again communicate to somebody, do a transaction with somebody else, they will check their ledger. Balance is anyway reduced now, so you cannot do double spending. Every time you spend, the balance is reducing. Now this is basically the principle. Only problem is now suppose A says let me make a fraud and I want to make an earlier entry to be changed. So I paid maybe 5 days back 100 rupees to B and I would like to deny that. So he will remove that entry. Now once that entry has to be removed, it has to be removed everywhere. Okay. And we just want to actually ensure that even if people collude, removing this particular entry is going to be very difficult. Of course, you need a collusion. More than 50% people has to agree. Okay. Here that yes, that 100 rupees were never paid to B and they have to make the upgradation in their ledger. Okay, in these records. But this record itself can be made immutable by making it costly to do it, because you have to do so much of energy has to be wasted in computing and it takes a lot of time. It is better not to do it actually. So this incentivizes that. So that's basically is the idea in the blockchain. So this is a distributed ledger. This as of now is not a blockchain. I can call it, I should not even call it a distributed ledger. So that's a word people use it. But normally distributed ledger means same ledger, so part of the ledger is here, part of the ledger is with this node, part is with others. No, it is the same ledger which is distributed to everyone. Okay, so same, there is only one ledger and copy is there with everybody. That's the way copy is with everyone. So that's how we should actually identify this. Now in this case, so far everybody else, we also wanted anonymity. So whenever the money is being transacted, in fact this was probably the reason why this got invented, that when you get transferring money, A transfers money to B, B should not know who is transferring and A should not know who is transferring to whom. Okay, so they become anonymous. Anonymous in the sense there is no unique user ID being looked at. But then how you will then identify A and B? So this was the same thing which we had done in the previous lecture. Every node will generate a public and private key pair. Okay. And public and private key pair, in this case this public key is what has become the identity of the node. And he need to know the private key so that he can prove to somebody else that he actually is the person who is identified by this public key. So this can be done again using SSL. Its principle is pretty same. A will B will generate some random number. Okay, and it will send this random number back to this guy. Okay, and this will be encrypted with the public key of A. The same thing which we had done earlier. A will be the only person who can decrypt it using the private key. So A knows this random number, and I can call it random B. So this random B he can decrypt, and then he can actually generate another random number which is going to be A, and it can use this random number A can be now encrypted with while transferring back with the public key of B. So this random number A can go here. Of course it is possible to send random B, but random B actually you can even send unencrypted, does not matter. Only thing somebody can tamper with this, but of course this can be digitally signed by random A, by the private key of A. So signatures can be done. So tampering can always be figured out. So even if somebody knows random B, it won't be able to crack the security actually. So when this random B comes here, okay, and only guy who knows actually what is a random B is this and this. If this guy is not the genuine person, random B must be different than this random B. So when B will figure out both are confirmed, so A is a confirmed person. Nobody else actually can confirm this otherwise. Only A can do this check. And random A is not known to anybody. It comes here and it actually random A and random B both are now available to him. Random A is currently known only to B and A. B has the private key, so he can decrypt it. So it can combine these two and generate a session key. And it can start, this guy also knows, this also has the session key by this time. Nobody else can make the session key because rand A is only known to A and B, and they can now communicate and confirm whether rand A has been correctly received by B. So if A and B both are genuine, then only this session key can get established and they can communicate. That's how the identity is being checked by each other, and they can do the transactions. So for being anonymous, again this same mechanism is used here in blockchain. So now when a transaction has to happen, we took this village example where of course the anonymity was not there. We were knowing that who is transacting with whom. But now those identities has been replaced by random keys. So we don't know actually who is a unique ID, except when the communication is happening. So surveillance agencies can figure out from which public key is belonging to which particular IP address. Okay, that much at best they can actually get it. But mostly everything is through encrypted channel. It's actually very difficult. Of course, once you localize, you can go and find out who is the person sitting there and catch him. That's a circumstantial evidence. Okay. So now A and B both now transact. That's important thing here. Let's come back here. They say the rupees 100 has to be transferred. So they will now make a transaction that credit to B actually should happen of 100 rupees and debit of should happen to A. In fact, if it's a bank account, this should be reversed. This should have been a debit actually entry and this should have been a credit entry. So bank accounts, that's the way it happened. Debit means increase of your bank account and credit means decrease of your bank account. Okay. So just being by accounting standards I have to be correct, so I have put it this way, but does not matter. This actually means the money is going from A to B. That's the way you should remember. This is only for notational thing. So once they actually make this record, they both will digitally sign this transaction. So how they will sign? So everybody knows, so the ID of node B is the public key of B, and it says that reduce 100 rupees from my bank, increase in 100 rupees here, and there is a public key of A, which is node ID, reduce 100 rupees here, then they will sign. So this will be private key will be used for this by A, private key of B. They both actually sign, and this transaction now can be distributed to everybody. Okay, so this A and B are sending it to everybody gets it, but how they will get it? You will now be using here your routing table in peer-to-peer network, which is based on logarithmic partition. So in few hops, you just simply do a broadcast routing and everybody will be having this record. And once this record is there, everybody can now put it in their transaction block. Okay. Now that's where now the blockchain comes, because people should not refute. So what they will do is, most of these people will make a record. Now another important thing they do is they actually now complete these records, transactions which are happening before they are not still confirmed. So everybody has to confirm and lock it, so that these cannot be reversed. So locking is what is very important here. So there is an earlier block which is going to be maintained. So there is always going to be some initial block, and there is a hash value which is computed. There are two important things. The hash, there is something called nonce, is a randomly generated number, and this can be anything arbitrary, but this has to be such that the hash value will have first 32 bits to be 0, for example. So they will be all zeros or any specified pattern. Remaining will be the hash value. So now this is done through a brute force approach. You have to keep on trying till you get 32 bits as zeros in the hash value, and that's when you say, okay, now I have got the correct nonce. So this hash value is being used as one of the part of the next block, and then there is a nonce here, and then there is a hash value computation. This is being used for the next block again. So when this hash is computed, this hash is over this all values, so previous hash also. Now when I computed this hash by identifying nonce, I cannot modify anything here, because if I do it, I have to do this whole chain, has to be computed, and this has to be done by everybody. So you will be having your, for example, here block, this block is not confirmed. So far everything has been confirmed. Okay, so you are now maintaining the entries here, so you add the entry here. There is something more which is done here. They basically keep on doing another thing. For example, they start doing some kind of a hashing, combining them. So as and when transactions happen, so there is going to be new hash which is computed, which is then going to be used recursively. So when an entry is made, it is not, it's difficult to remove, but of course everybody can do it. It is still not locked actually. And then when the time period comes, after a certain period, the nonce is, everybody starts computing nonce. They start all doing brute force thing till they find out a appropriate hash with first 32 bits 0. That's a difficulty level. So higher number of bits you want to be 0, it's going to be higher difficulty, more time it will take. And whoever gets it first will immediately inform everybody else. So everybody else will know what is the nonce which was selected, who is this guy. Okay, and everybody will verify if the hash will have first 32 bits as 0. If everybody gets it, yes, everybody has got the same set of transactions, and they will just put that hash value and they will now lock this particular block, and the new block will start after this. Now this actually computation takes a lot of effort, so it's not possible to change somewhere else. So normally if you have made an entry, if you made 100 rupees to B and minus 100 rupees to A, they remain there, you can't do much. If you want to reverse it, you create another entry somewhere in the later in the block where you will do 100 here and plus 100 here. Okay, you can only make the correction entry. So ledgers, normally even in the banks, you never do a correction. You always do a rectification entry is added. So once the entry is made. If it is made incorrectly, you make a correction entry. So all records are maintained. So you can actually do an audit trail. So now at any point of time, when A and B, before they are doing to do a transaction, they can actually check the audit trail. If they know the earlier balance of A, they can find out this whole audit trail can be verified by doing this hashing business, and they can find out what all transactions were done with A, so what's going to be current balance, whether the guy can pay it to me or not. And then only this transaction will be agreed by me and it will be communicated to everybody else. And when the block gets formed, transaction gets confirmed, a new balance of A will come. Okay, so that's when I will assume it's the confirmation has happened. I will give him the whatever thing which had to be transferred to him. If by that time I found the balance was not there, balance becomes negative. Okay, so in fact when these entries are made one by one, entries which I was talking about, okay, when you start actually doing keeping tracking using this particular hash values which are computed whenever every transaction is being added. Okay, so you cannot revert in between, and any new value which will check even to these transactions what is the current balance of A being maintained. So you will only accept the transaction when A has sufficient balance, and the moment this is done, it is locked. So now you can only look into the next block. So you have to only search through these transactions to ensure that how much balance is there. At the end of it, I know what is the balance. So balance for every node you can find out from the previous block wherever he has done the transaction. So this is why I did this, because I am now creating a chain. Chain consisting of blocks, and blocks will have all the transactions done in a certain period, and they are being logged by computing the nonce. So changing this block at the majority of the nodes is the toughest thing. So once it is done, it's done. So there is no bank involved, it's anonymity, and you can now do that. You have done the transactions also. Now what happens if a node leaves? That's fine. If a node leaves, the remaining nodes will keep on doing the job. They will keep on maintaining. When he comes back, he will find out he is lagging. He will just talk to the majority of the people and will update its blockchain part to the latest head. Okay, so longest chain it will pick up and will go there. Okay, so and if you are a new guy who is joining in, you can just copy what the blockchain which majority people have and then start working there onward actually in that. Now the guy who actually wins, computes his nonce first, is a winner. He should be given something. So there is a, by default there is an algorithm which says some amount of some delta money will be transferred or credited to his account. It is going to be generated. So that was like mining the money. So in fact that's the reason why all these nodes are also called miners. So not everybody does mining. Some people just only do the transaction, so they will talk to the miner and do it, but they won't compute the nonce. So people who are the miners, the majority of that essentially will always figure out what is the balance with everybody else. So there can be other participants also, but they may not be the miners. Now instead of rupees here, you just replace it by Bitcoin. That's what is being used everywhere. Okay. Now another important thing is that now since there is nothing else except private and public key as an identity for a node, if you lose your private key, everything which is the balance of public key is also lost unless you somehow recover that private key. So it has happened with people, and that's a difficult, that's the only tough part here. So normally you have to keep your copy of your private key with at some place so that you can always recover your bitcoins and use them. So as far as the peer-to-peer network is concerned, the only important part is connectivity. So everybody has to be connected if they are alive. So logarithmic partitioning ensured that. So routing tables are mutually exchanged and you keep on updating your routing tables. You can optionally use neighbor tables to keep on optimizing the network. Okay, and now once this is done, this is kind of was very popular for doing transactions, but transactions anonymously. As of now, if I know a public key, if I can find out IP address, I can locate the person. So people went even one step ahead and they built something called Tor. Tor stands for the onion routing. I will describe this in the coming lectures and probably the last in the series. Okay, so this provides anonymity. It's very difficult to crack that who is the guy who is sending it, and at every periodic step it keeps on changing. Your identity will still remain the same. So only two nodes A and B, when they are transacting, they know each other's identity. So on that actually you can do these transactions of between A and B, and then A and B can, any one of them can send it to everybody, all the miners, and miners can update it. So this was a pretty popular way of transacting the money there. In fact, there is something called a Bitcoin exchanges which are there. So you essentially do it through that. You don't participate directly. You buy that Bitcoin money from there or you sell it back there depending on the demand and supply. Okay. Now there is one more step people have thought as of now, because remember what is happening when A and B are actually transacting. They are doing some kind of a contract for something, and then as a consequence of when that contract gets fulfilled, the transaction of money happened. So people went and ahead and said, okay, we can split this process into two separate things. One is what we call smart contracts. So the agreement can be signed between them, can be logged and put it in this blockchain structure. And it is a programmable thing. It's kind of a code being put. So if there are certain conditions, if then else kind of things are matched, some transactions are going to happen, and they are going to be automatically happening. So all miners will keep a track of the smart contract. Whenever the smart contract conditions are matched, more than 50% people will see it. They will immediately make the ledger entry without even A and B telling them. Okay. So that's what actually also now people have been trying. This came to Ethereum. Now one of the problems which still remains is that you need a lot of computing power to compute norms, and we call it a proof of work. So somebody has worked, he has given the proof, and he gets a credit for that in terms of that miner's reward, that a small amount of Bitcoin which is being allocated to him, whoever cracks the nonce value. Okay. So, but this is a computation intensive thing. In fact, now it becomes harder and harder as the time goes by. And secondly, all records are infinitely increasing. Okay. So this blockchain will keep on infinitely increasing as time goes by. So everybody has to keep a larger and larger database for this. Okay. So your disk space will keep on getting consumed. But these are small records. It's basically A is sending into B, some hash values and other stuff. So it's not much, it's not a big data, but ultimately it will accumulate. So something, it has to be it's going to be non-sustainable in long run. Okay. So people have thought about now even to try some other different kind of mechanisms. So they call it a proof of stake. So you hold a large stake, you prove that, and that's when actually you are allowed to make the changes in the record. Okay. So it's like some in society, the guys who are well off, they are essentially being honored, and people have more faith on them, and they can actually be used as intermediaries for all the transaction records. This is typically the way it happens in villages. Similar kind of concept. So, but the important thing is that this was the transacting anonymously any value without any intervention of the bank, regulatory bodies or government was the reason why this Bitcoin or blockchain actually came. People had been trying earlier, but ultimately when this proof of work came, the blockchain came, the Bitcoins actually became feasible that time. Okay, but the all underlying network is peer-to-peer system where the routing tables are managed, and you do a broadcast here. It's not a DST routing being used to send to somebody else, except A and B when they are talking or negotiating, they can use DST routing. Okay, but once transactions are done, for transaction confirmation, it's a broadcast which is used.